Hello and welcome to SGN Tech Forum. This is another video in IoT Fun series, and this video is very important because I'm going to introduce another microcontroller. So previously we have worked with Raspberry Pis, but now I'm going to introduce another microcontroller, and this is an entry-level one called Arduino, specifically Uno. That's the platform I'm using, but there are various other uh, families, which you will see in the following slide. So the title is How to Work with Your Arduino and Analog Sensors. So let's see what we have in agenda today. First, what we are going to see, I'm going to introduce you to Arduino, why Arduino, what is Arduino. Then we will see the hardware. I'm going to do an unboxing also. Then you need to understand, if you are doing performing Arduino first time, then you have to understand the terminology. Then we will look at the software, and finally we will write our first program connecting an analog sensor. What is Arduino? Arduino, as I mentioned, it's an entry-level microcontroller and it's an open source. It's easy to use hardware and software. So the hardware and software is very easy to implement. And Arduino, they call it board. It can read input and turn that input into some output which can activate actuation. That means an action, right? Like turning on a LED or publishing something online, right? So you tell your board, that means Arduino Uno, and we'll touch base on board in a while. You tell your board what you want to do by sending the instructions, and then microcontroller read those instructions, processes that, and turn into an output, right? If you want to read more, this is the source, and we will definitely visit this website, arduino.cc guide/introduction. Okay. Before we dwell into Arduino or take a deep dive into Arduino, you must be wondering why another microcontroller, right? Because we have seen that you can work with your sensors and actuators and everything with the Raspberry Pi. Then why we need Arduino? So here is a quick comparison. Performance is definitely Raspberry Pi is more powerful and it's have greater performance. But power consumption, when you have the power restrictions, like in IoT, industrial IoT kind of scenarios, where you want your battery to last really, really long, that's where we need an Arduino. Then GPIO, Arduino has a inbuilt analog pins, while in Raspberry Pi you need to use a DTC, digital to analog converter, right? Cost, we will see the cost. It's very cheap, very inexpensive, and programming language support is Raspberry Pi. Because it has a full-fledged operating system. Functionality, obviously Raspberry Pi, again, because it has more power, more compute, and more processing. Okay, but it's not like Raspberry Pi is like scoring high in various points, but there is still a very good use case for Arduino, which you will see here in this video. A sample Arduino family, different kind of board. As you can see, Arduino Uno R3, Micro, Arduino Uno Wi-Fi with the Wi-Fi chipset, right? For our video, we are going to use Arduino Uno R3. So this is the board layout. This is how it looks, and you will see that when I actually go ahead and unbox it, right? So component, you can see it seems looks like pretty much the Raspberry Pi controller board. Here, the first thing what you have to notice is Atmega microcontroller. This is the microcontroller, and then again you have pinouts. Here you have digital input output pins, and then you have power output here, like 5 volt, 3.3 volt, ground, and all those things. And it has inbuilt 6 analog input pins. Then here comes power supply. You have a dedicated power supply, or what you can do, you can use USB port to power up your board if you are connecting Arduino to your laptop or a workstation. That's how you can power it up as well. Technical specification, again from Arduino.cc website. This is the board I'm using. So Atmega 32 8P controller, operating voltage is 5 volt. But if you are using a dedicated power supply, you can use a something like 7 to 12 volt power input. Digital pinouts, 14 pins, digital IO pins is 6, and input pins, analog input pins, 6 analog input pins comes by default. There are different kinds of flash memories there. Flash memories, SRAM, EEPRAM. Flash memory is to store your program, when you write your program, right, and upload it, that's where the flash memory comes in picture, and EEPROM and SRM is firmware and memory used during your uh, execution of instructions of your program. Clock speed and length and width is pretty small and very lightweight. All right. So the board, we have called this couple of times, right? And the board selection. So when you power up your Arduino, you have to select your board, and there are multiple types of board. I'll show you why you have to select a board, because when you select a board, it has two effects. First, it set the parameter like a CPU speed and baud rate and all those things, so that you can compile and upload your sketches. And I'll tell you what is sketch in a moment. So hold on to that. Um, and then some board definitely different. Okay, so I'm not going to read it, but you can find more about board here in the hardware. But you have to select the board so that your hardware is initialized. Okay, Arduino IDE or Arduino software, right, include built-in support for the board uh, in the following list, all based on AVR core. Board manager, there is a board manager. Standard installation allow you to support for growing number of new boards. So in future, if you decided to add a new board on top of for your Arduino, a board manager can help you do that, and we will see that in demo section. Okay, as I mentioned, sketch. The upper portion is what we call sketch. This is a screenshot from Arduino Uno Ide, right? So basically, where you write your Arduino program, the program itself is called sketch, right? As you can see, sketch, a program that runs on the board. Pins, a port that is connected to input and output channel. Obviously, the port you have seen, right? Digital, analog, and power pins, etc. You can have a digital pin and you can have an analog pin as well. So this is a sketch. Getting started. So before you get started, there are a few things you need to make sure you have it handy. First, go to Arduino website and download the Arduino IDE. When you try to download the Arduino IDE, you need to download as per your workstation requirements. So if you're on Windows or if you're in Linux or Mac OS, download that version of IDE, right? Then you have to make the connection. That means you have to connect your Arduino board to your laptop where you are running that IDE, right? And you're going to use a USB A to B cable for that. It will be used to power on as well as serial communication. Okay. Then you have to obviously connect your sensors to the Arduino board, because that's why you want to use Arduino, right? To read some input. Develop code on the IDE. Now you can write your program and upload it to the board. So you have to upload it to the board. You write your program in your local machine and then you say upload, and that time it actually pushes it to the microcontroller via serial connection, and then you can verify the output also. If you are not doing any real actuation, then you can verify the output via serial monitor or plotters, and all these things you are going to see in the live demo. Okay. So bonus, since for our demo we are going to use an analog sensor, and I'm using a potentiometer for that. So I put this slide because I wanted you to be familiar with potentiometer. So what is a potentiometer? We are going to use analog potentiometer. It looks like this. It has 3 pins, right? It's a 3-terminal resistor in which the resistor is a charge manually to control the flow of electric current, right? So basically you can read the voltage from this. And how the connection is happened. Here the center pin is your analog input, and then you 1 pin for ground, 1 pin for power. Okay, so this is the bonus slide. Now let's go to demo. For demo, what I'm going to do, I'm going to do 2 things. First, I'll unbox it and play a video so that you know what comes with the board and what you need to procure additionally. And then I'll show you how to download the IDE, give a walkthrough of the IDE GUI, and then finally we will make our connection of the board like analog sensor, and I'll connect my Arduino to my laptop and write a sample program and read the output. So pretty end-to-end demo, right? Okay, so okay, so here is the Arduino Uno R3 board. This I bought from Amazon. It's pretty inexpensive based on where you are. You can check the price, right? right? And so always make sure that you buy a genuine Arduino Uno R3 board. So this is the specification, what I put in my PPT slides also. So as you can see is Atmega 3208P, and memory, 3 types of memory, flash memory, PRAM and SRAM, and the clock speed, etc. So everything is mentioned on the board itself, right? When you unbox the board, I was hoping that there won't be any case for this, but to my surprise, as you can see, there is a base board, at least a plastic case available. There isn't a top cover for it, but at least there is a plastic case, which was really interesting. And these are the some pins. On one side you have digital pin, another side you have an analog pin and the power connections, right? And this is the chipset, Atmega 328 chipset. This is a dedicated USB A to USB B power connections, and then you have a dedicated power connection also. And this is the cable you need to use, right? One side is USB A, another side is USB B. Okay, so this is the board looks like, and now you know how to make a connection. Now this is if you want to draw more current from your analog pins, right, then you need a dedicated power supply, and this is a dedicated power supply looks like. So you connect it to the port and then you connect it to the power supply socket, right? But for our experiment, we are good with USB A to B power connections. Okay, I'm going to stop it here, and let's go to, we'll come back to this for connections purposes, but let's go to the IDE part. Okay, so this is when you download the program from Arduino.cc. You can come here and download. Let's first check buy an Arduino. When you click buy on Arduino, okay, I think unless you accept the cookies, it's really not working. Okay, maybe my internet connection is slow here. All right, let's you know from where to download the software, and I have actually put the link in the description. So here it will ask you to select the location. If you select the location, it's going to give you the price in the local currency, right? So this, as I mentioned, it's pretty inexpensive. You can buy a bundle with all peripheral, or you can simply buy a board as cheap as 26 point something dollars, right? You can also download softwares from the website itself, and I have already downloaded my software. But if you want to download, you'll come here, and then there are some stable code. There are some newer codes, and I'm running Arduino Ide 2.0 RC for Mac, right? So once you install your software, this is how it is going to look like when you open it first, right? So there are a few things. This is your first sketchbook, and this is pre-configured. So basically this is your initialization part, and this is your actual code. When I say initialization part, that means you have to set the serial baud rate and other parameters so that your laptop can communicate with the board, right, over the serial connection. And then here goes the actual code. What else you have here, if once you write the program, you have to upload the program. When you click the upload, that means it actually pushes the instructions to the microcontroller, and then when you click verify, it actually runs the program. Okay, then here you have a new, if you want to write new sketch, just like that, open. If you have any program on your machine, you can read it from there, or you can also download it or import it, the program written here, right? This piece is board manager. So there are a lot of board manager capabilities. One is already installed, but a few others are there. If you want to install based on the new board you are adding, you can do that, right? Then this is a library manager. Think of it like a different library functions. And here it's a debugging, so you can debug. And finally, anything search for board manager, and you can search here, right? So right now you can see my board is Arduino Uno, but Arduino Uno is not connected, which is true because my Arduino Uno is actually not connected, and I'm going to connect this to my laptop brown. Okay, as I connect this, you'll see now it says Arduino Uno and it already detected my serial connection. Okay, if I run this, as a sketch uses 1% of your program, that means it was this program which is locally on my laptop was actually pushed to the microcontroller and I can see things, right? So its connection is already there. And now if you want to write a program, before we write a program, let's look at the setup. Here you can see I'm going to make a setup here. So here I connected a potentiometer on my potentiometer on my baseboard, and I have three cables going. One red cable is for 5 volt, black is ground, and yellow is going to A0, which is my analog input, right? So this is how you are going to make a connection, and finally the board is connected to my laptop. So let's go back now, so you know the connection. Let's go back and try to write a program. But if you are new, how you can write a program? You don't know the programming language. So for that, what you can do, you can actually go to a menu option, and here you can see you have multiple menu options like board. By board is already selected to Arduino Manager, Arduino Uno. But if I want to select another board, I can go to Board Manager and select some other board, right? But that's not what we want to do. So what um, you can also select the port. So my right USB serial port is connected, and so these two are by default. This is one time thing. And then if you want to monitor your output, here is that serial monitor serial plotter, and we will see when we run our program, right? So we don't know the program, how we can run a program. So the good thing is there are few examples, built-in examples, and we are going to use one of the built-in example, which is called read analog voltage. As I select that program, a new window opens up and my program is loading. This is pretty simple program. Reads an analog input on pin 0, that's where I made my connection, convert it to the voltage, print the result to the serial monitor, right? And graphical representation is available in using serial plotter. So we have made the connection, we will run this program, and I'm going to uh, tune my potentiometer so that we can watch the output changes in serial monitor as well as serial plotter. So let me upload this, hitting upload. Okay, and before I run the program, I'm going to open serial monitor. Okay, and I'm going to open serial plotter. Serial plotter opened here. Let me put it here. Okay, and run the program. Verify serial monitor, serial plotter. Now let me change the potentiometer reading. As I change the potentiometer reading, you can see it will go towards 5 and try to stabilize. Now if I'm rotating it clockwise, it will go down to 3, 2, and 1, right? And all that real values you can see real time in serial monitor as well as serial plotter. Let me go back to 5 again. So I'm increasing anti-clockwise and it is increasing my voltage. It will go to maximum, which is very close to 5, right? Because that's how the program is written. So this is all I wanted to show you around Arduino Uno. I hope this will give you enough confidence to start your IoT journey. We have seen a lot of things like sensor, actuator, Raspberry Pi, and the final thing was Arduino. Now I'm going to put one last video, which is actually how to take this sensor actuator at your home and communicate it to the cloud, right? And that's what that will be like our final or end goal, and that will conclude this course. And I'm going to call this course a Zero to Hero IoT series. And you can watch, if you have not watched all the video, you can watch all the video together and get started on IoT journey. So I hope the entire series of video has been very helpful to you, and if that is the case, please do like and subscribe and share. And also, if you have bought any gear or you did your first IoT experiment, please do let me know how was your experience, or if you want to share something with me or ask any questions, please do so. Thank you.